All right, so we're now going to move on to our next video, and this is our last video and last section before our next quiz, and that is going to be section 3C and factoring expressions. So what you will need to be able to do by the end of this video is you'll have to know what a greatest common factor is, and the way that you will see me or hear me talk about that going forward is just GCF. So you have to know what a GCF or greatest common factor is, and then you'll also have to know how to factor an expression using a GCF. All right, so we're going to talk about greatest common factors a little bit, but this main video is just going to be going over some examples. All right, so before we get into any examples or talking about GCS or anything, I just wanted to tie this into what we have done before. So if I gave you this and asked you to simplify, you know that this is telling you to multiply because of the parentheses, and we would distribute the 6 into both of the terms and get 6 times 2x is 12x, and 6 times negative 1 is minus 6. So when we go to factor, what we're actually trying to do is figure out, well, what did we multiply to get to 12x minus 6? So we are actually undoing the multiplication that we just did, and our goal is to rewrite this back into the 6 times 2x minus 1, so that this way we can see, well, what did we multiply to get to this? 12x minus 6, and that is factoring. So factoring is undoing the multiplication that we did. All right, so we're going to go through a more formal definition now, and then we'll go through GCF, and then we'll go through 3 questions together. But just know that when we factor, we're undoing the multiplication and trying to get back to the starting point to figure out, well, what did we multiply to get here? All right, so as I was just explaining to you, factoring, so let me just put this real quick above it. So factoring, the definition of factoring is finding out what to multiply to get to an expression. And it's also something you might hear as factorizing. And what we talked about before, that when we are distributing or multiplying, we will distribute it in to get 2y plus 6. And then when we factor, we are undoing the multiplication that we just did and figuring out, well, what did we multiply to get to this 2y plus 6? So all it is just finding out what multiplied to get to that expression. All right, that is what factoring is. It's undoing the multiplication. All right, now let's talk about what a GCF is. So a greatest common factor is the largest number that divides evenly. And that's a key thing you have to remember there, evenly. So it divides evenly, so it means it goes into it a whole time. And it's the largest number divides evenly into 2 or more numbers. So for us, in our examples, we're only going to be focusing mainly on where we're looking at the GCF of 2 numbers, but just know that this can extend to more than just 2 numbers as well. But the greatest common factor is the largest number that divides evenly into whatever set of numbers you're looking at. So if we look at this 12 and 8, and we want to know what a GCF is, one of the things we can do is think about, okay, well, what numbers divide evenly into 12? Well, 1 and 12 go into 12. 2 and 6 go into 12, and 3 and 4 go into 12. And then what numbers divide evenly into 8? Well, we have 1 and 8, and we have 2 and 4. The number that you will never, ever, ever use when we are factoring anything is that number 1, because every number will share 1 as a factor. So we'll never use that as our GCF. So if that's the only number that they share, then there is no GCF. So then from here, we look and see, okay, well, they both share 2, and they both share 4. So when we're doing this, we would say, okay, well, 4 is our GCF. So our GCF between 12 and 8 is 4. So let's go ahead and see how we can use a GCF when we're going to factor an expression. So let's go ahead and do some examples now. All right, so now let's go ahead and do this problem and factor the given expression using the GCF. When we get to our third question, or maybe our second one, I'll talk about why the GCF is important. By using the GCF, it does allow to make sure that everyone who factors this question will get the same answer. All right, so that's why we have to always use a GCF. So what we need to do first is identify, okay, what numbers or what number is our GCF between 15 and 25? And maybe it might jump out at you and maybe it doesn't. So I'm going to write out all of the factors of 15. So 1 and 15 and 3 and 5 are the only factors of 15. For 25, it's only 1 and 25 and 5 and 5. So I look, the only one that they both share is this number 5, because remember, we'll never use the 1 anyway. So that means our GCF between 15 and 25 is 5. So that means that's what we must have multiplied in to get to this if we want to factor this completely. So what we're going to do now is we will write, okay, well, that's a GCF that they share. So we're going to write 5, and we're going to write the parentheses because we know that we would have distributed this 5 in to get to this 15x plus 25. And all we need to do now then is figure out, okay, well, let's divide, because we are going to be multiplying, and we know the inverse operation of multiplication is division. So we're just going to go ahead and divide each of these terms now. Well, 15 divided by 5 is 3. And don't forget your x. And 25 divided by 5 is 5. So when this factors out, it is factoring out to 5 times 3x plus 5. So you see there's no GCF that is shared between this 3 and this 5, so we know we factored it out completely. And if we want to check our work, we simply can just redistribute this 5 back in, and 5 times 3 gives me 15x, and 5 times 5 gives me 25, and you see we start back at our original problem. So when you're doing these factoring questions, you can always check your answer and work to make sure you're doing it correctly. All right, so then the next question we're doing, the same thing, factor using our GCF, is 24x minus 16. So we need to rewrite this as a multiplication problem. So let's go ahead and look at our factors of 24 and 16. And you don't have to do this every time, but if you are struggling with this, then it's good to write out all of your factors. So we have 1 and 24, 2 goes into it 12 times, 3 goes into it 8 times, 4 goes into it 6 times, and you see the next number is 5, which is completely sandwiched in between here. And since 5 doesn't go into it, I'm going back to 6. I know I went through all my factors that actually go into it. So it really doesn't take us that long unless the number is really large to see all these numbers that can go into it. And 1 and 16, 2 goes into it 8 times, 3 doesn't, and 4 goes into it 4 times. So we only have to write that 4 once. So we'll go through and highlight all the numbers that they share. So they both share 2, they both share 4, and they both share 8. So the largest number, or our GCF, is 8. So that's the number that we will go ahead and factor out. So I'm going to do this problem over here because I'm going to show you, well, what happens if you don't use a GCF, and I'll show you that second. So we know that we can then factor out the 8. I'm going to rewrite it as 8 times. And then I'm just going to divide each of these numbers by 8. Well, 24 divided by 8 is 3, so it's 3x. And negative 16 divided by 8 is negative 2. So don't forget that sign that you have there when you are factoring out. So this factors out to 8 times 3x minus 2. All right, and we see that 3 and 2 that's their prime numbers and they don't share any factors, so we know we did this correctly. So what happens if you do take out a number that's not its GCF? Well, let's just say I said, okay, well, they're both even, so I'm going to take out a 2. So if I were to rewrite this as 2 times, and I divide each side by 2, I get 12x minus 8. Well, you see here, both of these numbers are even, and we can still keep going. So maybe you want to say, okay, I'll take out another 2. So when we factor out this 2, remember this is being multiplied. So when we factor out the 2 this time, let me change this color. So now I'm going to factor out a new 2, which will be 2. So now we had to multiply it by that 2 that we originally had out there as well. 12 divided by 2 is 6, so 6x. And 8 divided by 2 is 4. So now we have 2 times 2, which we know is equal to 4, times 6x minus 4. And if I wanted to, then I'm like, okay, well, 6 and 4 are still even, so I know I can still factor out another 2. So now I'm left with 2 times 4. When I divide 2 from both of these, we then get 6 divided by 2 is 3, so 3x, and 4 divided by 2 is 2, so minus 2. And then we would have to do the 2 times 4, which is 8 times 3x minus 2. So you see, even if you needed to do it step by step with smaller numbers, you'd still get the same answer. It's just obviously a little bit quicker and faster if we can identify the GCF from the beginning, but it's not the end of the world if you can't. All right, there's one more question that we're going to do, and then that'll be it for this video. All right, now this last question we have is negative 36x plus 12. And one of the rules that you have to know when we're factoring is we always will want our variable or our leading variable. So in this case, it's just an x. If it was x squared, we always want it to be positive. So for us, it's always just going to be x right now, but we always want it to be positive. So if it's negative, that means right away when I go to factor, I'm going to know I factor out a negative number because I want to change this to positive. And the way that we factor and we're going through our work is we're dividing. So we know a negative divided by negative will give me a positive, or when I distribute this back in, a negative times a positive will give me that negative. All right, so we always want to rewrite this leading variable as a positive number. So 36 and 12, well, for these, 1, 36, we have 2, we have 18, we have 3, and we have 12. I'm going to stop there because I see it's 12. And my other number is 12, so that means it's got to be our largest number. So I know I can factor out then a negative 12. When I divide each of these by negative 12 now, not positive 12, by negative 12, a negative divided by negative gives me positive. 36 divided by 12 is 3, so it's positive 3x. And here we have a positive divided by negative is a negative, and 12 divided by 12 is 1. So this is 3x minus 1. One of the things I always see kids do is when they factor out, if this gives us a 1 at the end, they'll just want to rewrite it as this. We will never, ever, ever have a lesser amount of terms. So here we have 2 terms. When we factor, we'll always have the 2 terms as well, because when we multiply back in, we still need to get back to where we began. So a lot of kids will want to write this because they think, oh, 12 divided by 12, it's nothing. Well, it's 1. So that is not how we will write our answer. We always need to make sure that we're putting that 1 at the end to show that when we distribute this back in, we would get that negative 12 times negative 1 gives me a positive 12. All right, so just make sure that when you guys are doing this, if your leading coefficient is not positive, it's negative, you want to factor out a negative with it to change it to a positive. All right, that is it for this video.